Hello, everyone. Welcome to my channel, and thanks for visiting Joe Dawood Academy. In today's video, I wanted to go over some problems regarding to the average rate of change. This is a continuation of the previous video that I posted recently on the YouTube channel. And I just want to go over some practice problems that you may encounter uh, in class during a quiz or part of your test. This is more like problems that are geared to just give you a little bit of a hands-on practice with respect to the content. And eventually we'll be going over some harder, more difficult problems in later videos on the channel. But in this video, I want to just go over some practice regarding the average rate of change and how to do the calculation when you're given a word problem. So in this case, let's dive right through it. And just before I start, I just want to ask you, if you like this channel, please subscribe, click the subscribe button, and also just make sure you click the bell notification icon. I will be posting more and more videos regarding math and sciences and biology, microbiology, biochemistry, and other courses as well, physics. So it'd be great if you want to join our community, my little channel, my community. And if there's any questions you needed me to go over concepts in future videos, please feel free to comment below. And so we'll get right to the problem here. And what we see here, it's given, we see a table of values given to us. And basically it's time in the first column, and we have volume in liters, time is in minutes. And the first part of the question is asking us to find the average rate of change of the volume of water in the tub for each, and they give you three subsections. The first subsection is asking for the first 18 minutes. So as you know in the previous video, if you have a table of values or you have coordinates, these can be used to calculate the average rate of change, which is the slope of the secant. The slope of the secant being the line passing through 2 points on a curve or on any graph. So in this case, we don't have a graph, but we have the table of values, and the table of values gives us these coordinates. Now we need to know, in our case, what is the independent variable and what would be the dependent variable. Now, in most cases, like 99% of the cases you would encounter, time is the independent variable. Since time is not really dependent on anything, just keeps on going, other parameters that we measure against time, those can be modulated or changed with respect to time, or they may go up or down. You may see shifts or they may stay stable, but they're really not changing. Well, they're changing as time changes, or they may not change, but time we usually treat it as the independent variable, or x on the coordinate axis. So in this case, we'll consider the time being our independent variable, x, and the dependent variable is volume. And we can also pick that out in the question because they're asking us to find the average rate of change of volume, how volume is changing in each tub. And volume is changing with respect to time. As time passes by, we can see that the volume is changing. So time equals 0, the volume in the tub is 1,500 liters. A time equals 6 minutes. So after 6 minutes, the volume is 1215 liters, and etc. We see that there's a trend already that the volume is dropping. Now, let's go to the first part, and to find the average rate of change, you need to first look at the change in the y-axis, so the rise over the run, or the change in y over the change in x, and we know the y variable is the volume. So leading on to y2 minus y1 over x2 minus x1. Okay, great. So we know that's the change in y over the change in x, and we know y is the volume. So we go back here, and now we have to identify some points. So if I want to find for the first 18 minutes, The first 18 minutes is from the starting point, time equals 0, and up until 18 minutes. Okay, so my two coordinates that I would be using would be, the coordinate axis starts x comma y, would be 0, comma 1500. And the second point, or the second coordinate axis, would be 18, comma 735. Okay, great. So now we have the 2 points that we can use to find the average rate of change. And usually you can use any point. You can start off with any point as long as you, whatever point you start with when you want to enter into the formula, that's the point you consider, for example, your y1 or x1, y1, or you can consider your x2, y2, but as long as you stay in the order, you don't want to mix and match the coordinates where then you would get an error. The answer would not be correct. So I'll just quickly show you that here. This is my x1, y1, and this is my x2, y2. Okay, and then moving forward, average rate of change equals, so my y2 in this case is 735. My y1 is 1500 over 18 minus 0. Okay, so we quickly calculate 735 minus 1500.